balancing this equation, I took the first step and wrote down the equation larger so that we'd have more room to sketch around it. Then I'm going to separate it down the middle, down the yield sign, and start counting up the elements. Carbon has 1 times 5 carbons. Hydrogen has 1 times 7 plus 1, 8 hydrogens. Oxygen has 1 times 2 plus 1, 3 oxygen. On this side, carbon has 1 times 1, 1 carbon. Hydrogen has 1 times 2, 2 hydrogen. Oxygen has 1 times 2 plus 1, 3 oxygen. In these problems, where oxygen or any other element is scattered between different chemical compounds, it's usually best not to try and evaluate or not to try and match up oxygen first. So let's start with something a little more simple. How about carbon? Carbon is 5 on this side and 1 on this side. Therefore, I'm going to put a 5 in front of this carbon, which turns the carbon into 5, but it also changes the oxygens. So I have to recount the oxygens. 5 times 2 is 10 plus 1. Now I have 11 oxygens. Next, I'm going to change the hydrogen. 8 on this side and 2 on this side means that I have to put a 4 in front of this. 4 times 2 equals 8. When I did that, I changed the oxygens, so I'm going to recount all the oxygens, not just add oxygens, recount them all. It's easy to make a mistake if you try and just add oxygens, but recounting them all ensures fewer mistakes. It's no longer 11. It's going to be 5 times 2, 10, plus 4 times 1. So 10 plus 4 is 14. Now at this point, a lot of students get confused. They try and balance the oxygens, but they're unsure how to do that. The easiest way, I think, to think about it is just solve the number one problem that's confronting you. This 3 is an odd number, this 14 is an even number. So what if we can make this side even and then catch up this side later? This is 2 oxygens, so no matter what we put in front of here, it's not going to make this side even. This is 1 oxygen, so if we modify this, we can make the oxygens even. The easiest way to do that is just do 2 in front of this to modify the oxygens, and other things will change. Don't worry about the other things, all we care about is the oxygen right now. So if we put a 2 in front of here, oxygens change to 4. 2 plus 2 is 4. Now carbons change. Carbon was 5, now it's 2 times 5, 10. And the hydrogen change. 2 times 7 plus 2, 14, 15, 16. So this becomes 16. Since I put a 2 here, it becomes easy to modify these. If this carbon doubled, then whatever's here should also double. this number should become a 10, which makes 10 carbon here, 10 times 1, 10 carbon. But now the oxygens change also. So it's going to be 10 times 2, 20, plus 4. So it's 24. And then we need to change the hydrogens also. 16 and 8, well, I just need to double it. So if I double 4, that's 8. 16 hydrogens. But the oxygens also change. 10 times 2 is 20 plus 8. 28 oxygens. Then I need to go back to here to fix the oxygens. Right now, since oxygen is split up into 2 different chemical compounds, or 2 different chemicals, I need to find a way to separate this chemical from just the O2. So what I have total on this side is 28. So I want to get this side to 28 total. But I have to take away this chemical so I can deal only with the O2. So that means I'm going to do the 28 oxygen from one side, and I'm going to minus the 2 oxygen that are here. So that means I need 26 oxygen. The 26 oxygen are going to be what's left over for this chemical. Now, since this is a 2, I can just do 26 divided by 2. This coefficient, therefore, has to be 13. These are going to be the coefficients of the answer. And that's roughly what the complete answer should look like. You want to make it a little cleaner. You want to erase this 5 and this 4. Like that. And then bring the 10 down and bring the 8 down.